Exciting part. All right, so we are live, everyone. My name is Jesse, and I am with Exploring by the Seat of Your Pants. We are all about bringing conservation, adventure, and science into classrooms and homes around the world. And I want to take a second before introducing this broadcast because I have the best job in the world. I get to showcase amazing scientists, explorers, people from all around the globe. But even by that standard, today is really special for me and special for you guys watching at home, either live now or after the fact on YouTube and Facebook. So, the research vessel Falkor, the RV Falkor, is one of the elite research vessels in the world. Basically, there are only a handful of ships that get to go around the world in pursuit of epic science and exploration with the top people on this planet. And we've been really privileged over the last few years to feature them in over a dozen, maybe 20 plus now sessions, highlighting all the amazing people and all the amazing work they do. But even by that standard, today is really special. So the ship is in the Coral Sea. It's the Great Barrier Reef and beyond. It's one of the most unique, incredible geological, biological habitats in the entire globe. And right now it is stocked with a team of some of the best researchers on this planet using some of the coolest tools and toys and tech in the world to explore this unique and amazing habitat. So we're so excited to get to share that with you today. I'm going to turn it over to John, who's the lead marine tech and the team of the RV Falkor, in just a minute. We currently have the ROV exploring, so you are live with us as we're getting to showcase exploration in progress of things that have never been seen by people before. So it's super exciting. And without further ado, I'll turn it over to John. There's a 10-second delay because I'm in Toronto here in Canada. He's all the way on the east coast of Australia, so it's a bit of a delay, but we're going to keep it as nice and cool as possible. I'm really looking forward to your questions as we go on with the broadcast. And again, without further ado, I'll turn it over to John. So John, thank you so much for joining us today. You should be unmuted and good to go. Tell us all about what you guys are up to.
Hi there. Thank you very much, Jesse. My name is John Fulmer. I'm the lead technician on RV Falkor on this cruise. We are currently diving on the Trigossi Reef, which is east of Cairns, Australia, out in the Great Barrier Reef in the Coral Sea Marine Park. And with us today, we have Gemma and Antonella, who are researchers on this cruise. And what you can see in the background is live video right now from a mid-water transect that we're doing with Dr. Dougal Lindsay, who is currently in Japan. So you'll see him pop in the top left of the screen every once in a while there. He's doing commentary. You can check out that dive and any other live dives that we're doing at the Schmidt Ocean YouTube page and the Schmidt Ocean Facebook page. And we'll have a little bit of a roaming camera from Dean Miller, our correspondent, who is doing multimedia outreach for us, and he can show a little bit of the control room and give you guys an inside look at how we do these dives. You can see we're currently at a depth of 185 meters. We will be going down to about 500 meters. So depending on how quickly they descend during the dive, we'll be able to see the benthic transect that they'll be starting. But first, I'll throw it over to Jeremy. If you want to kick us off, you can fire your mic up there.
Hi, my name is Jeremy Horowitz. I'm the onboard marine biologist, and my job is to help the ROV team decide what corals to collect. And when we collect those corals, we'll bring them onto the boat, and then we preserve the corals and put them in bags like this. And we bring them to the museum, and then they get deposited in the museum and then later worked on by various experts to better understand how these corals live and, what corals live in these habitats.
Hi, my name's Gemma Galbraith. I'm also another onboard marine biologist. I'm assisting with a lot of the specimen preparations when we do our collections. But my own research is focused a lot on seamount ecology, which is a really cool key part of this cruise that we're doing. So I study the fish and coral communities that live on the top of these giant undersea mountains. And it's been awesome on this cruise that we visited quite a few of these amazing underwater seascapes. So yeah, I'm loving all the dives. We get down to the seabed and we'll trundle along there for a bit doing collections, picking out things we've never seen before. and then we gradually make our way up the slopes of these seamounts and canyons all the way up to the shallows. And a lot of what I do is start looking out for, fish that we maybe don't expect to see so deep, or potentially even new species.
Hi, I'm Antonella. I'm doing my PhD in marine robotics, and I'm on the ship to collect some data for that work. So basically what I work on is using cameras to enable robots to navigate totally on their own. So create maps of their environment and navigate through their environments autonomously. So I have a little vehicle on board, which I think I'll show you later. And that's what I'm using to collect data. So I got to go out a couple days ago on close to a shallow part of the reef and collect some camera data, which then I'll use to develop mapping and navigation algorithms.
Wonderful. And so I'll shoot over to some video that we've collected on the cruise here. You can see an octopus we found down at the depths, and some of the midwater jellyfish and everything that Dougal is currently explaining, but this is just some of the highlight video in the background. And Dean has entered the room. So Antonella, would you like to give a little explanation of your ROV?
Sure. Just slide over here. Yeah, so this is my vehicle that I'm using as a data collection platform. It's built off of a commercial system that you can just buy off the shelf, but I've added a lot of customizations to it. So when you get the ROV off the shelf, it's designed for teleoperation. It's not really designed to be autonomous. So it doesn't have the sensors and computing power that we really need to be able to enable autonomy research. So I've added on some downward facing cameras here, you can kind of see, and a second payload computing platform with computers that enable us to collect high resolution data at a high frame rate. So it has onboard storage capacity, a lot more onboard computing power. And eventually, we're hoping that right now it operates as an ROV, but eventually we want it to be untethered and actually just roaming through the environment on its own, figuring out what's cool to look at and bringing back data that the scientists can then use to understand whatever ecosystem we're studying.
Okay, wonderful. Thank you, Antonella. So as you can see in the background, there are some more shots of stuff that we've collected down at the sea floor. We've been going all over the Great Barrier Reef for the past 2 or 3 weeks now, kind of getting lost. We've been at sea for a while. We're diving almost every day. So what we do before we reach a location, we have multi-beam mapping sensors, acoustics on the hull of the ship. So we will map the area that we're going to be diving on, and then we create a 3D rendering of the surface down beneath us, and the ROV team will use that to navigate through the different channels and over large surfaces and the rocks that we have down there. And the research team will be able to check that out in the morning right before we plan our dive, and using some more data, the backscatter, which gives us an idea of what the bottom type and the sediment is made up of. They can plan their transects and kind of pinpoint the areas of interest that we want to go down to. And I'll let Gemma show us some of the stuff that we've found down there.
Cool. So this cruise has been the coolest opportunity for me. I'm really interested in seamount habitats, and usually when I do my research, I'm working pretty shallow, sort of up in the upper 30 meters of the sea's surface. But if you imagine this sort of seascape of the ocean floor and this massive cone as an underwater mountain, being on board the Schmidt boat, we are able to drop down way below where I normally do my work and, hit depths of sort of 1,500 meters. And it's really showing us just how much more of these habitats there is yet to explore. So normally the dive will start with this sort of mid-water work we're seeing with Dr. Lindsay at the moment. looking at sort of what kind of animals, organisms, plankton we see drifting along as we drop down, down, down. That'll take a while sometimes if we're going pretty deep. Can take up to a few hours, and then eventually, what you'll see, watch all the way through that video, is we'll hit the seafloor. So maybe 1,500, 1,600 meters. Although I think the Schmidt ROV crew, they can actually get Sebastian down to something like 4,000 meters. 4,500 meters, yeah. So that's pretty deep. And then you see the ROV hit the floor. Sometimes a little cloud of sediment puffs up and you're there. And then you're kind of just getting your bearings. You're figuring out where you are, looking around. And, the ROV guys on board, such a great job of just letting us explore for a bit and see what we can see. Right now, there's some footage of just down in the sediment. We find all these crazy critters, stuff you just don't see up in the shallows. And then we begin to climb all the way back up again. And what I think is so cool about doing these long dives is you get to see everything. You're down in the deep for so long, and then you start emerging. It starts to get a bit lighter. You're seeing things that are a bit more familiar, still things that are very unfamiliar. This is some cool footage we've got going on in the background right now. Jellies, crabs, squat lobsters, octopus, and then you pop out right in the shallows again, up on those coral reefs that you get out here in the Coral Sea, and feels a bit like a dream sometimes. But that's sort of a typical dive for us. But we're seeing new stuff every day, and a lot of Jeremy's work is focused on looking for things actually that science has never seen before.
Yeah. Do we have video of collecting some of the corals? So while we're down there, so we're down underwater for about 4 to 8 hours, and during that time, what we're looking for are soft corals, hard corals, black corals, and sponges. And each of these groups will be grabbed with the ROV. So the ROV has arms and hands, basically fingers. And what it does is we find a coral, and we decide we're interested in it and we want it, and the arm will come out, it'll come down, and it'll grab the coral, pick it up, and put it into what we call a bio box, which is essentially just a container within the ROV. And we'll get footage of that. But so we're able to collect all these different amazing corals and sponges, and a lot of them are new to science. So this is the first time that we're able to collect biology with an ROV in the Coral Sea and the Great Barrier Reef. And what that means is it's the first time we're really seeing all of the different living things that are in these deep habitats. They've been mapped for many years, so we know kind of what the seascape looks like. But the question is, what lives in these habitats? So we have the opportunity with the ROV to go down, grab things like this. These things are in perfect condition. So we've never before been able to get species like this that are collected with precision and care. So when we bring it up to the surface, we know exactly this is what it looked like when it was underwater. And this allows us to identify what it is. What is the species? And how does it differ from other species? So we start to build a kind of checklist of all the living things that live in these habitats. And we have permanent records with these corals. So it's an amazing opportunity. Scientists spend their lifetimes trying to get specimens that look like this to advance their work and advance our understanding of corals and how they have evolved to what they are now. So it's an amazing opportunity to be on the Schmidt Ocean Institute, Falkor.
Wonderful. Thank you, Jeremy. And just to give you guys an idea of what the control room looks like, Dean's just going to pop over to the control room and give us another shot here. So we'll switch back to this camera here. Jesse, do you guys have any questions or anything for anyone while Dean gets that set up?
Yeah, certainly. We actually just got one a second ago. Adrian Feldman on YouTube wanted to know, where do these deep sea corals get their energy from? I think a lot of people know that corals sort of have this affiliation, get some of their energy from sunlight with their zooxanthellae, their algae, and their tissues. So these ones that are way down deep, how are they getting the energy to stay alive and grow?
Yeah, it's a really good question. Right, so the shallow corals get their energy from sunlight, but in the deep, at 2,000 meters, there is no sunlight reaching the seafloor. So what these guys will do is they have little arms, so tentacles around their feeding mouths or their polyps. And what those little arms do is grab little particles. So you could see in the video behind us, those little particles around this jellyfish. So this is what we call a marine snow. So a lot of this is debris from living organisms that comes from the shallow down to the deep. And so these corals will be able to grab those particles out of the moving water and put it into their mouths. And that's how they get their energy in the deep.
Fantastic. We're in the control room.
Yeah, so what you're seeing right now, that's the pilot station on the left-hand side and the co-pilot on the right. And during the midwater transects, the pilots actually have control over the video camera, so makes it a little bit easier when they're trying to chase something that's either floating away from them or they're descending. They can kind of keep up with it. When we do get down to the seafloor, we transfer control over to the scientists so that they have control to take the 4K camera and zoom straight in on whatever specimens they might be investigating. And then on the right-hand side there, you see Nelson. He's one of the other marine technicians who's running the live stream at the moment, so he can shoot between different shots, focus in on whatever the people might be narrating. And then up in the top right there, you can see Dougal Lindsay, who is Zoom calling us in from Japan right now. So he's been wonderful for us to give incredible commentary on all of these critters that are in the middle of the water column. Stuff that normally when we're descending down to the seafloor, we kind of zoom right past. And I mean, it looks cool, but without the in-depth knowledge that he has to share, it's kind of just another jellyfish to a lot of people. But then you can see over on the far end is Dr. Scott Nickel. He is the principal investigator or the chief scientist for this cruise. And then behind him is Dr. Rob Beeman, who is one of the co-chiefs. And after this, if you guys want to tune into the live dive when we get down to the seafloor, you'll hear some really interesting stuff that they'll have to share about that. And I'll bring it back into the library here where we're speaking with you.
Fantastic. Thanks, guys. So that live dive, that's going to be in your Facebook channel, correct? Because if that's so, I'll bring it up on the banner so that people can see that and find that link for when we're done.
Absolutely, yeah. So we're live streaming at the moment. So if our video is a little choppy for you guys, it's because we're out in the middle of the ocean. We're doing live streaming of 720p to Facebook and YouTube, and we're taking Dougal Lindsay in on Zoom, and we're also broadcasting out to you guys. So if it's a little choppy, we apologize, but yeah, kind of testing the limits of the technology at this point.
And we really appreciate it. Again, we've got people joining from all over the world, so we so appreciate people tuning in. And do check out that Facebook link. It's on the bottom of your screen right now, so you can check that out and go there either now or when you're done. Get some really great video. Let's keep the questions going. So we've talked about the ocean floor and this fact that most ocean exploration is in this higher zones in the first 30 meters. How much of the ocean floor has actually been explored, either by you guys or just in general around the world? Like, how much unknown territory is there?
Yeah, another great question, and it's definitely true that we know more about the surface of the moon than we do the depths of the ocean. So the stuff that we're able to do out here on Falkor is just, it allows us to jump forward leaps and bounds with our knowledge of deep sea habitats. I think especially for seamounts, there's estimated to be somewhere between 100,000 to 1 million of these structures across the oceans, varying in size and shape and depth. But only a handful have ever really been visited, let alone surveyed. So, our crews right now focusing in on seamounts and deep sea canyons is really contributing to that body of knowledge that until we've had technology like we have on board Falkor was pretty inaccessible to scientists. So this expedition really makes you feel like a kind of explorer. You're definitely doing things that haven't been done before, seeing things that haven't been seen before, and hopefully if we continue like this, we'll be able to build up some pretty cool maps of the global oceans and all of these cool features that we're getting to see on the ROV dives. Amazing technology and an amazing kind of time to be involved in deep sea science.
Fantastic. What a great answer, guys. A quick follow-up on the RV element to this. So again, we've talked about the fact that you use autonomous vehicles, remote operated vehicles. Why not go down with people? What is the benefit of sending robots, either autonomous or controlled, down to these depths as opposed to going down with people in submersibles, if there's any?
There's definitely an advantage. The primary advantage is the amount of time that we can spend at depth. So obviously a submarine has to have a life support system for however many scientists are on board. And that really limits both the number of people that can come and observe and the amount of time that you can spend, especially at deeper depths where you have a lot of time that's spent diving to whatever depth you're working at. With an ROV, pretty much we're limited by the number of samples that we can take. We can dive until the bio boxes are full, or obviously we have to come up for maintenance and such. But for the most part, we can be exploring almost perpetually. And we can have a lot of scientists in the room with different backgrounds rather than having maybe like one scientist in the sub and a couple of pilots. We can have, all these scientists on board the ship, each with different backgrounds, and they can all be kind of looking at the different parts of the ecosystem. So we have geologists who, know about the marine geology, and biologists, and that I think really can increase the amount of exploration that we're able to do. So ROVs are pretty awesome in that regard.
Fantastic. It's something that we hear a lot in our space presentations too. People always ask, why send robots, why send probes instead of astronauts? And it's exactly the same reason. So again, these challenging, really incredible environments often are better explored for all the reasons with robots. I'm glad we got that question. All right, Patrice in North Carolina wants to know, what's the strangest animal you've seen? And a second question from them while we're at it, are you seeing much in the way of coral damage? Strangest animal, and is there any coral damage?
Can you maybe type the question?
Hi there. Sorry, Jesse, you broke a little bit there. If you can type a question out, we'd be happy to answer, but it's a little bit cyborg voice there for us.
No worries, will do. Let me, there we go. Bring it up on the screen for you guys.
Wonderful. Yeah, we've got that. Thank you.
What is the strangest animal you've seen?
Ooh, that was a good question.
On it.
Sure. Well, what is the strangest animal we've seen? We've seen a few. I think for me, it was a few days ago. We saw a benthic living comb jelly. So this is a heart-shaped blob of red-looking goo that sits on the bottom of the seafloor at about 800, 900 meters. And it looked like something from space, couldn't really figure out what it was doing, whether it moved, and just awesome. So that was weird. We've seen cute. We've seen pygmy seahorses, which crazy critters really in themselves, hanging out on Gorgonian sea fans at about
Over 100 meters.
at least over 100 meters. And we even saw a shrimp party.
Yeah, saw a bunch of shrimp having a little party.
Yeah.
I think we're gonna get the image of so this is a nautilus shell. So there's like a prehistoric animal. This is what fish is this?
This is a type of monkfish, a deep sea monkfish.
Here's an octocoral. Here's a black coral with a
Squat lobster.
squat lobster on it. We work on different groups. This is a black coral, Parentopathes black coral.
We collected that one, I think.
Yeah, that's what this is.
Yep.
What we have here. A jelly.
It's not a jelly. That's a cutlass fish. Yeah, so many weird and wonderful creatures. It's just mind blowing, you know. And then something more familiar. Got a nice shark down, still pretty deep though. These zoom in shots we get on the 4K camera on Sebastian they're just incredible.
Yeah, it's better than we can take with our cameras on board.
Totally. This is another type of jelly. Oh, here's the shrimp party.
So they were really interested in us as much as we were interested in them. And then here's a Gargonia with a brittle star wrapped around it.
This is now creeping up into the mesophotic. We're getting a bit more light there, more fish.
Yeah, some sort of crustacean.
Isopod
Big, giant isopod.
related to terrestrial wood lice. This is a coral trout relative.
And here's the pygmy seahorse. So it's only a few millimeters tall, and it's really rare for someone to find a pygmy seahorse while scuba diving, let alone with an ROV that's the size of a car. So we were really lucky to spot the pygmy seahorse, on the sea fan. So it's really amazing. You get to see lots of things living on things. For this example, we were looking at the Gargonian sea fan, and then we noticed something moving within the sea fan. And then we saw this pygmy seahorse. And they're very cute little critters. And yeah, it makes for some great footage and probably a range extent for the species because, like I said, it's hard to survey in the deep. In the shallows, we know where they occur. They occur, and
Let's see if we can get them back. They've cut out for just a quarter second, which can happen when you're broadcasting from a ship in the middle of the ocean across the world. Oh, they're back. Got them back. Hi, guys. You just disappeared for a second, but you're back now. And there's this really freaky creature that's on the screen. That's a good follow-up. What is that?
Yeah. So, what is this? Jelly?
Probably some kind of siphonophore. So it's actually a colony of lots of individuals living together, making up that big string. And if they break up, they'll go start their own little colony. It's kind of one of the ways that they reproduce. But yeah, so cool to see these. These are tiny. We're drifting down to the bottom of the seafloor and taking our time with Dougal to look at these things just adds such an extra dimension to the variety of creatures we see across our dives.
Unbelievable. How cool is that? Thanks, guys. All right, we have a 7-year-old, ND on Facebook, who wants to know, how does it collect samples and bring them to the surface without breaking them? So can you explain how you get those samples back up the surface intact?
Yeah. So with fish, because they have chambers of gases, when they bring them up to the surface, their bodies can change shape. And a lot of people have seen things like the blobfish, which looks like a very ugly fish when it's brought to the surface, but it's actually a very cute fish underwater. But the things that we're collecting, the corals and sponges, they don't change their shape when we bring them up from very deep. And that's because they're just made of this hard material. So the black corals and the hard corals, they're all made of this hard, solid material that won't change based on the pressure change from however the pressure is down at 1,500 meters up to the surface. So what we get is exactly what it looks like when it's down at depths. But of course, that'd be a different story when collecting fish.
Great answer, guys. Okay, so Isabella, you talked so casually about modifying a super cool sea robot to build better equipped to deal with all these amazing conditions and see all these cool things underwater. How do you get the schooling? What kind of training do you need to be able to so confidently do that sort of awesome work? What do you do to get that expertise?
So people can come at it from a lot of different backgrounds, but engineering training is really helpful. Engineering or any kind of hands-on work, whether that's mechanical stuff, electronics, or software. So my background is sort of a hybrid between mechanical engineering and software, computer science, although a lot of my work is in the algorithms and the math and the software behind mapping autonomously. But I think you can come at it from many, many different backgrounds. I think the coolest thing about something like robotics or ROV work in general is it kind of integrates a lot of different disciplines, and it's really helpful to have sort of an understanding of the applications you're targeting as well as the intricacies of the vehicle. I've worked with ROV pilots with a biology background, but then move into learning the technical systems, and then they work pretty much only on ROVs. So I think there's space for pretty much anyone with curiosity about exploring the deep ocean.
Fantastic. What a great answer. Thanks so much. All right. So one of the questions that we've gotten in a lot of these past broadcasts is how do you choose your dive sites? Why go here? I mean, we can explain why it's so cool. Why choose a specific spot amongst this whole ocean of discovery that you can make?
Sure.
Yeah, great question. And I guess when you're planning one of these trips, it is so easy to get carried away with, oh, we should go here and check this out. We should go here and check that out. But a lot of science is really focused on your sampling plans. So you're making choices based on previous knowledge of a site, whether you know a little bit and you want to go and expand on that and answer a particular question, or whether you know nothing and it's a real gap in our existing knowledge. So one of the principal investigators, one of the senior scientists on board, Dr. Robin Beeman, has done a lot of mapping in the GBR and Coral Sea region previously. So he's had a really great sort of foundation map that we've been able to plan our surveys with. And so we spot holes, places we haven't been and mapped, and we go, yeah, need to get that area mapped. Dr. Scott Nicol, another senior scientist on board with Geoscience Australia, has been studying a lot of the marine geology of the Coral Sea throughout his career. And so we're kind of led by a lot of our prior knowledge and really want to jump into filling in those gaps and continuing to expand our exploration.
Nice. Great answer, guys. So we've talked about this expedition a bit in general, and John started this by saying you guys have been out at sea for a while. How long are these expeditions? We talked about numerous dives that you guys have been on. How long is the ship out at sea? How many dives will you do? What does a typical trip look like for you?
Yeah, Jesse, I think we got the gist of the message. Of how long are we able to stay out at sea, and how long do the expeditions generally last?
Yeah. So in total, we've been out. We will have been out for about a month, and we came back to shore about halfway through the trip to change some of the crew, but some of us have stayed on for the entire time. So about a month at sea. And each day we try to get at least one dive going. So, and that one dive could be the whole day. They like to keep the dive restricted to daylight hours. So, it could be 8 hours of diving. So you have, the entire day to go down, explore, collect, look around, and then come back.
Oh, we lost you for a quarter second. You're almost back. Sorry, we just missed the last sentence. The last sentence we missed. So if you could repeat that, we're good.
So so after some of these long 8-hour dives, the next step will be to bring the ROV back to the surface, and then we have another 3 or 4 hours of processing all of the corals that we've collected. So it could be very long days, but always very exciting. I think every single dive we find something that we didn't expect, and it's just extraordinary. So long but very rewarding days at sea.
Nice, great answer, guys. All right, Adrian's got another great question. I'll bring it up on the screen too. Do lights scare most of the creatures? When you're down there shining these bright lights, do things flee from you? How do they respond to the lights? Is there any other way you could attract them? Or
Yeah, that's a good question. I think some animals are scared of the lights and the sound. And so we don't see many sharks when we're doing these ROV dives, but we know that lots of sharks are living in these habitats. When we go scuba diving, we see sharks, on most of our dives, especially when we go down and we get to look out to the blue, into the deep. We see lots of sharks, but we don't see them on these dives. So I think we're scaring the sharks away. But the smaller fish probably don't have the ability to swim away really fast. So we get to see some of the smaller fish. The lights they don't seem to affect the animal life that we are observing. They don't really shy away from the light. So it doesn't seem to bother them much.
Excellent, guys.
Even hang out with us. We had one dive where we had a bunch of amberjacks, these kind of big fish. They just hung out with the ROV for about half an hour, just following us around.
Yeah, we might be providing them with some extra sight to see their prey. So maybe they're using our ROV light to catch their food.
Yeah, very cool, guys. All right, so I want to segue off this to another question for Antonello. So obviously, as we continue to do dives to the deep sea, we are getting better lighting, we're getting better camera technology. What are some of the cool things that we've developed in the last 10 years and maybe have coming down the pipeline to better explore the depths, whether it's charting them to begin with or taking great pictures when we're down there? What are the cool tech things that we have that have developed in the last decade or so?
I think I got the gist of it. So I'm a little biased towards autonomy because that's what I work on, but I think that's some of the tech that we're going to see in the last decade and in the future become more prevalent in ocean exploration. So right now, like, these ROVs are really incredible tools, but they cost a lot to operate. It's a lot of people running this expedition, and even though you have a pair of eyeballs on the seafloor, you're only seeing one tiny spot. What I'm hoping to see, and what we've seen sort of a move towards this, is more autonomy, whether it's autonomous underwater vehicles or surface vehicles, or even just tools on the ROV to do more like automated processing. I think that's going to really increase our ability to explore the oceans. So one classic example is a lot of quote unquote AUVs. They are autonomous, but you give them a waypoint to navigate to. And you'll see, it'll be flying across the seabed, and you'll see, a picture of sand, a picture of sand, a picture of sand. Oh, there's something really cool. A picture of sand, right? Like, it doesn't actually know what's there. It's not doing any processing of what it's seeing. It's just sort of passively taking images. And so, from that survey, okay, we found something really cool. But I think the next generation will be, maybe if that AUV has some sort of higher level autonomy in its algorithms, to be able to say, oh, that's actually really interesting. We're going to modify our survey now. We're going to check this out for a while before continuing to our next waypoint. And then what my sort of vision would be is, once we have a fleet of AUVs going out and finding what's cool, then we send the ROVs down and can get really precise, people looking at what's there, bringing back samples. And so just kind of more of a distributed way to explore the ocean, because as we already discussed, there's so much we haven't seen of the seafloor. And we haven't even seen it at a resolution that, for example, biologists can really see what's there. We need something like an ROV. So if we can kind of expand that to autonomous technologies, we might be able to say, hey, Jeremy, we found something really cool. Now we can send Sebastian down there. That's sort of my dream. We're not quite there yet, but I think the technology in the robotics field is sort of moving in that direction. So that's what I'm kind of hoping to see more of in the ocean exploration space.
Fantastic. I want to follow up on that, and I know that the audio is iffy, so I'll bring it up on screen as too, so you guys can stab at answering that. How do we train them to better explore? Is there something that people at home could help with in training these robots? Like, this sounds amazing. So I'd love to get us involved.
Yeah, okay, I can see it. Yeah, so one of the things that a lot of people talk about is machine learning. And machine learning is sort of a hot new thing, but it's harder underwater because we don't have as much data as we do for things like facial recognition, where we have really enormous data sets and we can train algorithms to classify things or recognize faces, for example, with really high accuracy. Underwater, some of the things we're discovering are new species. We don't have any data of that. And so we're not able to just put down, a magical machine learning algorithm and see, oh, this is what's on the seabed. We need scientists to be looking at these things. With that being said, I think there are some citizen science efforts with coral mapping that I think people can certainly get involved in, or just collecting data wherever you happen to be, and maybe making that available to some scientists who might not be able to go and do field work in that area. I think there's definitely a place for citizen science and all of that. But I think, in terms of the algorithms, more data is always better.
Nice. Thanks so much. All right. I'm going to take a couple more questions before we wrap up. This has been really fantastic, guys. You guys are awesome. And whoever is navigating between all the screens is doing the best job of anyone I've ever seen in one of these broadcasts. So kudos to you. All right. I want to bring up a question by Miss Reeves. She's one of the best teachers we've ever had in the history of exploring by the seat of your pants. And this is her question. Are your days totally planned when you dive, or can you make your own decisions about where you go and what you do with a rover?
So generally, the day before, we have a rough idea about where we want to go and what we want to do. But that is all underpinned by the weather, the currents and the temperature, the wind currents, and then the subsurface current and the waves. So often we'll get to a site and then we'll see the weather, and then we'll decide either to go with our plan or to modify that plan by going somewhere that's a bit more protected. And we just had a dive yesterday where we went down and our plan was to go down and then slowly come up to the surface. But then the weather got bad, so we had to abort the dive. So often the plan is just it's a rough sketch of what we think we might do. But in the end of the day, it really is a moment by moment decision based on the current conditions.
And also what we see, I guess, we've had some dives where we just didn't know what to expect when we dropped down, and suddenly we're seeing all this amazing stuff, and the plan was maybe just to shoot up a couple 100 meters, but there's, it's so cool and worthwhile to spend a bit of time down there. Then we modify our tracks maybe, and just kind of keep things flexible in terms of seeing as much as we can.
Yeah. Guys. All right. I want one more question from someone on Facebook. So I'll get Ms. Reed. One of the topics we're exploring all September long with Exploring by the Seat of Your Pants is marine plastic, something that a lot of schools are focusing on. And so specifically, is there evidence of plastic at the depths that you guys are exploring? When you go and explore these reefs, do you find plastic pollution down there or not?
We have found things that humans have dropped. So not specifically plastics, but we found beer bottles and cans. Often we find them in locations where people tend to fish. And we also have found lots of fishing line, really long, thick fishing line. And again, it was at a location where there are people, on top of the water doing either fishing or leisurely, boating around. So we do see effects from humans at the depths that we're exploring. And even deeper, there have been lots of records of plastics down at 4,000 meters deep. And, you wonder, how can something get there? But if enough is going in the water, it'll make its way to the deepest habitats in the world.
Great answer. Kind of disheartening as always, but it's something that, again, with plastic pollution, it's something that no one wants to see that there. Everyone can work towards solving it. So if that upsets you, if that sort of knowledge is bothersome to you, there's lots of things that you can do at home to help. Well, before we wrap up, guys, whether it's the team there, John, is there any last message you guys would like to share about the Falkor, where you're exploring this expedition in particular? What can we share with people as a parting message?
Well, so the main question really was, what's living down in these habitats? And we now know that there's a lot. There are species new to science, species that we didn't know occurred in this part of the world. And what that means to us is that this area is worth protecting. And even more, it gives us the information that we need to protect it really well. So before, when the Great Barrier Reef was being protected, they didn't know where to put protected areas where people are not allowed to fish. But now we have a lot of information. We know where things occur, how far things extend. We know what the substrate is like. So now we can say, all right, if you protect these areas, you will save more species than if you were saved these areas. So that was the information that we were able to get from this cruise. And so what it will mean is we're going to we're going to be in a better position to protect all the living things that are down in the deep sea.
Ladies, do you have anything to add?
Yeah, I just think one of the coolest things about this expedition, aside from all the exploration we're doing, is being able to share this with everyone back on shore. So much of science, you're either locked away in a lab or out in some remote place. The technology that Schmidt Ocean Institute have on board RV Falkor is just an amazing way to kind of distribute our efforts and what we're finding with so many people. It's just so cool to be able to, do what we're doing now and also have all our dives recorded for people to watch again and pick out stuff they found cool and interesting. So yeah, that's definitely a real highlight of this kind of expedition for me.
Yeah, I think for me, the highlight has definitely been being able to see the technologies that we use for ocean exploration, and also test out new technologies like my vehicle, for example. I know Schmidt is really supportive of not just using the tools that we already have, but building the next generation tools. And that's, I think, really exciting to see as we continue with ocean exploration, getting new technologies that allow us to explore even further into the deeper parts of the ocean. I think will be really exciting.
Thank you guys so much. It's been such a privilege. I mean, all those answers lead into the fact of exactly what we're doing right now. It's such a thrill to get to share these amazing creatures, these amazing stories, all your expertise, again, with students around the world. So thanks so much for all you guys are doing, and we look forward to helping share that word out to all our colleagues for months to come. So thanks so much, and hope you guys have a wonderful rest of your expedition and a wonderful rest of your day. I know you're just starting off. What time is it in the morning there? How far away are we from Eastern time?
10:20 in the morning.
Well, there's always coffee. Well, again, I'll end the broadcast there. Thank you guys so much, and we look very forward to hearing from you soon, okay?